So I guess we should start. Is it too dark or is it okay? Is the lighting okay? Can you see from your? Try to see if I can. Is it better? Okay. So I guess this is the first time we use this because the first class was canceled due to the irrigation ceremony, and the second one is canceled due to mid-autumn. So the first time we use this classroom. So the goal today is we will finish the topic 1. Hopefully finish almost all of them, or at least left just some of them, so that I will release the first homework. Probably for the first one, we give you a little bit more time. For that, I put it out later today or tomorrow for the first set of the homework. So what we're going to do today is we will finish this topic. We will finish the covariance and correlation coefficient, and then we run an exam. Okay, so if you have time, we will talk about probability. So it really depends on whether we can go to the second one, but we should be finishing this one. Okay, so just a very brief review what we have done. I guess we don't review what the data is and so on and so forth. Just this slide would be sufficient for the review purpose. The first one is central tendency, and we learn the mean, the median, and mode just to remind you what are they. And mean is just the center of data, which is by distance, and median is exactly center data. You don't care about the distance. It's just the you arrange the data from top to bottom or bottom up, then you just find the middle guy. And the mode. And for dispersion, we learned 5 different measures, right? There's a range where the formula would be the maximum minus the minimum, or the largest minus smallest, depending on you do the ascending or descending order. The next one is quantiles. Quantiles, you divide them into 4 parts. You just take the boundary of the first and second will be the Q1, and boundary of the third part and the fourth part will be the third quantile. And the difficulties lies on how you define them exactly when you take the data. And there are many ways. As I mentioned in the class, there are at least 9 different ways. If you look at Stata or R or any software package, they will at least have more than one method. The way we do is the one of the method used in Excel, which is the method 3, which is a quantile function, and I expect you to use it for your assignment and your test or your project. So that's the one we're using. Okay. So the idea of it is just a linear interpolation. Okay. But I'm not going to elaborate. I mean, if you have a question, you can just go back and check the examples. And the next 3 measure variance, standard deviations, and coefficient variation are all measured based on the idea we call the square the distance from the mean, and we care the average square distance. And the reason why we don't use variance that often than compared to standard deviation is because of unit of measurement. And again, this idea applies. Those are why you sometimes see the coefficient variation, because you want to don't want to be affected by the measurement unit you're using, and don't want to be affected by location of mean. Okay. And the next 2 things we cover is called kurtosis and skewness. So the idea of it is just to remind you that the skewness is just measuring how symmetric data is. And the formula looks complicated. Just to remind you what the formula is, it's just a fraction. And this fraction, look at the denominator, the simplest, this cubic standard deviation. And the numerator, okay, is very similar to what we have in the variance, right? The variance is up to square, but we have to the cubic. So just to remind yourself what is different between cubic and square is when you have cubic, then you can have negative, right? Because of square, you learn from the multiplication of negative numbers, right? Negative times negative, right? It's positive. Positive times positive, positive, right? So, but negative, you always, if you start with negative, you still remain as negative, right? So if the data point is left or smaller than the mean, right? In that case, negative, then this guy, you raise to the power 3 still negative, right? With on the right-hand side of the x bar or more than x bar, right? Then you'll be positive, right? So that's why if your data have a lot of data point that is outliers towards the positive side, then it's skew positively, right? The right skew. Just to remind you that mean is exactly in the middle in terms of distance, right? So the cubic must be talking about things are extreme value, large away from the mean, right? It's just like because the mean is exactly in the middle, right? So that's why when we square, so when we raise to the power 3 and it's not 0, it means that it must be the case that some value deep away from the mean, okay? So just to remind you what are these graphically, just to remind yourself how you do it, just look at the graph. So the typical graph when you have a skewness of series like this is symmetry, okay? And a typical graph of positive skew like this, okay? Of course, in this graph, I have only data with only single mode, right? It's also possible that there's something like graph like this, right? Can be, right? You don't have to, looks like just say one peak, right? But it can be multiple peak, right? Or something like this is also possible, right? But as long as you have a very big tail, right? Here, relative to the mean, right? Then you would have this positive skewed data, okay? And negative skew like this, right? Just to remind you the idea of negative skew is because a lot of data that's far away from mean, and then you raise to power 3, right? And this is much closer, okay? So that's the idea you have this. And just to remind yourself why you would be using the skewness measure, right, is the fact that if the data is skewed, then you have to worry about whether use the mean and variance is sufficient for your analysis, right? Very often when you look at finance data, you look at the mean and variance, right? That would be sufficient when the data is not skewed, then you don't have to worry about things. But if the data have been shown has a big skew, whether negative or positive, then you have to think about your assumption, right? Because usually when we do later UC, we assume or call bell shape or normal distribution, and that case is symmetric. So things are much easier to handle. But of course, the data, you feature this kind of skewness, that requires special skills that we are not teaching for class, okay? So for this skewness, it's not something we can handle. Data skewed that we are not able to handle for our class, but doesn't let you know that if your things are not perfectly nice, you have some skew, then you have to need some extra measure. So basically, this is a warning signal for analysis that if your data doesn't do very well, you need to be careful. Okay, so that's we want to say the same caveat applied to kurtosis, right? In our kurtosis, remember, is a measure of the thickness of a tail. Okay, just do the thickness tail. But what does that mean? Let's go back to the formula. Against a fraction, the denominator is very similar to the kurtosis, right? So just raise to the power 4, and this raise to the power 4. So everything is same, exactly same as kurtosis, but instead we have raised to the power 3. Okay, so you may quickly ask what it is, right? Because skewness would have the denominator, you can have negative, positive, right? So which tells you whether the data is skewed to the right or skewed to the left. So what is the kurtosis set, right? And indeed, that is not too much, the idea is not too much different from the variance, right? The variance is like, if the data far away from the mean, then you got square. right? So the larger variance means the data is more spread, okay? And kurtosis is because raised to the power 4, right? So the further away from the mean, the data is way more exaggerated than the variance, right? So that's why you divide by the variance again, right? That's SD. So that means that is if the data have a lot of outlier, right? Outlier either on the left side, right hand side, the kurtosis is very big, okay? So basically just checking outlier, I think kind of like outlier checking, right? Checking there's a lot of outlier. And as a comparison, right? Skewness to compare 0 or non-zero, right? Kurtosis compared to the benchmark is 3. You compare the 3. It's bigger than 3, then it's much thicker tail than a bell curve, right? The normal one, which we'll learn after 2 topics, right? Topic 3, we learn normal. Same idea, if below 3, then you would saying that it's much thinner. Again, this is a check from the data, okay? In our modeling, we're not able to handle this, right? What happened when the data is very skewed? What happened when the data is very fat tail? We are unable to handle in our class. But bear in mind that it will be important, okay? So that is something we cannot handle, but in some sense, right? But that would be taken. You should take into account when you really do it. And I mentioned last class, right? Why you have a financial crisis because of some people said in 2007 there are a lot of algorithm trading, and those algorithm trading are designed by people said is by a Ph.D. in physics and Ph.D. in math who have no knowledge about economics, and they fail to take into account of kurtosis and skewness, not because they don't want to take to, but because of the fact that if you take account in the skewness and kurtosis, the model will be very complicated. And at that time, people just don't do those. And of course, now they do, but I mean, in those days, they don't take into account those. So that's why bad things happen. But if you are studying actuarial science or quantitative finance or insurance people, then they will know actually kurtosis is important, right? Because mainly insurance mainly is talking about catastrophic or highly unlikely event, right? And those actually is basically about kurtosis, right? I mean, if you talk about normal, then it's not going to work, right? You talk about human life, right? And then people have life expectancy of like in Hong Kong, it's like 60 to 80, right? So you don't expect the risk of death or injury is going to be normally distributed over the course of life, right? So that's why they have a life table, and there's some table that detect accident and those so on and so forth, right? So that is the idea. Similar the idea of income distribution, right? And if you are you are the government, right, trying to give the cash voucher, right? You are not going to assume you're going to have a normal distribution, right? Because the cash voucher is most likely to helping people who do not have high income, right? If those people have high income, that actually give them that money, it doesn't have to be helpful, right? So that's why a lot of time people arguing how to model an income distribution in the society, right? So if you use normal, then not be very well, right? And you have to use certain kind of distribution, right? Poisson or even negative binomial or whatever that would be, or extreme value distribution. There's a many way to do it, but that is very important. Looking at kurtosis, they try to see. Okay, so just a minor technical thing is when you try to estimate that the sample versions like this. I know the formula is complicated. I'm not expecting you to memorize those, but I put it there because either Excel or software package, what they give is this formula, right? Instead of actually give you this one, actually you can calculate that for Excel, right? But later you will see today, we'll go to Excel, then you will see this is the one that we'll be using, right? Same for kurtosis, although they work with a complicated formula here for excess kurtosis, right? This one, okay? It's complicated, okay? You don't expect to reproduce that, right? But you know what you're calculating when you put it in Excel spreadsheet, okay? And some of you may ask, I only have sample excess kurtosis, right? What about sample kurtosis? That's simple, just add 3 to the end. Because the difference between the excess and non-excess is just 3. But actually, as you see, I mean, no one cares about the kurtosis by cell, right? We only care about excess kurtosis. So just like give you, and this is what the Excel gives you, right? So later you will see at the second part of our class. Today we'll tell you, right? This formula is just KURT, right? K-U-R-T, but we'll do it after the break. So I'm not going to go calculation step by step. I guess it should be intuitive. In case you don't know, then you ask me. But I guess I don't want to spend time on this. But in the rare scenario you don't know, you can just email me or just ask me during the break. We can talk about those. Just spend time on more important thing. Is there a question? If you want me to go over the example, we can go over that. But we just want to save time. If you really want, I can just go over the view. But if not, then we just work on very last thing we want to look at. Is so far our data only focus on one measurement from each individual, right? So talk about income, talk about price of the stock, talk about various measures. We only have single measure for each individual. And very often we have more than one measure. And very often we have two measures. We want to know how they're related, right? For example, you may be care about X1, X2 whether someone may got COVID disease, right? And Y1 may be how many vaccine they've taken, right? So you want to look at how many jabs they have done compared to how likely they got the disease, right? So these are the information you want to do. Or one way often use example in or often studied in economics or business is the problem of education and income, right? We care about we study more or study harder, is it going to benefit us, right? For many of you, maybe you're interested in knowledge itself, but we also care about the monetary return, right? Is it going to more educated people would be more income, right? That may be the problem when you graduate, whether you want to study 1 or 2 more years for the master program, right? Whether you want to do the MBA, right? They involve a lot of time cost and money cost. You want to do that, right? Of course, this is a very difficult question. How to discover the causal relationship is a very important thing. It's easy when you have a lab, you can do experiment, right? But for social science, a business is very difficult to have a control experiment, right? So that's why how to do it correctly is a difficult thing, right? And later you will see the most thing in our class talking about hypothesis testing, ANOVA, regression. The last 3 important topics is basically focus on looking at cause and effect. Want to try to at least look at the correlation, look at their relationship. So here we are looking at the measure that try to look at how they're related, okay? We're not talking about causal relationship, just looking at whether they're related in statistical sense, okay? So it's not talking about one thing cause the other, whether X cause Y or Y cause X, right? Because there can be something called Z, right? Maybe one guy is very smart. So that's why he can be good at education and also good at making money. So we don't know. We're just saying that is it high income people tend to be more educated, right? Or more highly educated people tend to have more income, okay? Unless we can say one thing happened before the other, right? And then probably we can have some causal interpretation, okay? But for the moment, we don't talk about those. We just talk about how they're related, okay? So there are 2 measures that related to this relationship, try to whether they're related, right? So one is called variance, covariance, the other is called correlation coefficient. And later you will see they're basically the same thing, okay? Just a different normalization. Basically, you can imagine the covariance is just variance, okay? And correlation coefficient is just basically coefficient of variation, just normalized, okay? So basically they're measuring the same thing, but it just one is not scaled, one is not, okay? So as you can see, the names are just covariance. Oh, don't have a nice graph here, but so let's then covariance, the idea is whether they move together in the same direction, okay? So let's look at the formula, then let me explain in graph. Okay, that would be easy to see. Okay, so look at this formula. Okay, this formula is actually very similar to variance, so that's why you can see the covariance. And if x and y the same thing, then this is exactly the variance formula, right? But x is same as y. That means that you can replace this guy, right? That's become square, right? If x and y are the same. Okay, so that's why it's basically the idea. That's why they call covariance. And what they are talking about in this formula, okay, is the following. Okay, if asking whether they move above the mean together or not. Okay, so if x is above the mean and y is above the mean, this measure will be positive, right? If for any observation that's above the mean for x and the y, xi minus y bar and yi minus y bar positive, right? Similarly, if they're both negative, they both below the mean, they are all positive, right? If one is above the mean, one is below the mean, they become negative, right? So let me draw a diagram to show you that is the case. Okay, so let's see the problem. Okay, let's see the scenario that you may be expecting. Okay, so let's see. So let's do a scatter plot here. Okay, and y. Okay. So let's plot some data here. Okay, and let's see the following case first. We do different scenario. Okay, suppose the data is like this. Okay. This, if you see this data, you expect the x and y are moving together, right? So how to quantify this? Okay, how to quantify? So let's first find what is x bar. X bar. X bar is somewhere here. Remember how we found it? Look at all the x. Okay, look at the distance to the right, and distance to the left. Okay, are the same. They give you the x bar. Okay. Similarly, you can find the y bar. It's somewhere here. Okay, because look at all the measurement, the distance. Okay, it's exactly in the middle. Okay, so why this is when we measure the covariance, that will positive, right? The covariance measures, okay, let's copy here, but you think I think you did in your slide. Okay. So in that case, you calculate every observation. Okay, let's pick up one observation. This observation, green observation. That observation, green observation, is above the mean for x, right? Because on the right hand side of x bar. Okay, it's also above, it's bigger than y bar because it's above the red line. Okay, so for both entry, they are positive, right? Positive times positive, then this entry positive, right? So same for all the entry in this region, right? They are positive region. Okay. Similarly, look at all the entry here. Okay. X minus x bar will be negative, right? And y minus y bar will be negative. Negative times negative, positive. Okay. So that means that every entry you end up adding together divided by n positive. Okay. So that's why in this example we have covariance is bigger than 0. Okay. So that is the idea when you look for covariance. Okay. So that this measure fit our idea when we want to say positive, right? So let's see the example of negative, right? Do we expect the same? Okay. If that fit, then it is a good measure of what we want. Okay. Okay. But actually, you can imagine what will be happening. Okay. So the data like this. Okay. Y. Okay. Now let's look at the x bar and y bar. So the X bar is here. I don't want to explain again. I don't need to do that. Just left and right equalize, right? The distance. Okay? The distance for each point, you just add up the distance. Left and the right the same. Okay. Same here, you have this idea. Okay. And now we try to look at use the orange one. Okay. I pick up a point, say this one. Okay. I pick up the orange dot here. This orange dot has x coordinate, x bigger than x bar. Right? But the y coordinate is lower than y bar. So this entry will be negative. Right? Because one is positive, one is negative. Right? And same for all of this. Okay. The similar case you can see here. But x and y just swap the rows. Okay. For this one, x is being below the x bar. All right. For y above the y bar. So it's negative. So it's positive. It's negative and positive. Right. So this is also negative. Okay. So every entry is negative. Right. So you can see the covariance is negative. Okay. So that is the main idea behind this covariance. Okay. So when it's likely to be, you can see this. You can based on the mean and of x and y, you can cut this into 4 different areas. Right. If the data is more on the northeast side and the southwest side, it is positive. Right. If more data is on the southeast or northwest, you will be negative, right? So that is, we can distinguish which case, right? And of course, it's 0, then it's likely to be falling, right? So you cannot tell which is more likely. Okay. So and that's ideal covariance, right? If the larger the covariance, more likely that they will be more extreme, right? More further away in those areas. Is that clear? What do we have covariance? Okay. No, that's nice. No question. We go back to this one. Okay. So that is our idea. Okay. So as we have said, for many measurements we have learned, this is something we're interested in. This is called the covariance population measure, right? But we have a sample counterpart. That means that when we try to want to know from the data, that's the formula we use MIG. Okay. So that is okay. And then I want to say, is there any question for the covariance? If not, then we can go to what we call covariance coefficient. But if you understand what is the covariance, you should have no problem understanding this, because this is just this is covariance. Okay. We just divide them by its own ST. Okay. Divide them by ST. Just divide them by power variation of x and y. Okay. You may ask, why do we do this? Okay. There are 2 reasons. First, covariance have a unit, right? Depends on how you measure x and y. Okay. And if you divide it by them, then the measure, what we call the covariance coefficient, do not have any unit. Okay. It doesn't depend on the unit we are measuring. Right. Second, the good thing about this is we always have here, we always have -1 to 1, okay? Which if you want to prove, you can prove it by no math actually coming from the courses. I think the courses was in college. I don't want to go into the math, but we can prove it's always between -1 and 1. Okay. So what is the good thing about this is when you have 1 that is everything on the straight line, -1 also on the straight line. Okay. If not, then it's less than a straight line. Okay? Just let me do a picture. What you have is the following. Okay, just to let you see the idea. Right? So let me use one color. If the data is like this, you can fit in on a line. Then what we call is this rho xy is exactly 1. Okay. In the other case, if everything is on a line, okay, on a line. On the line, then this guy will be -1. Okay, and if you have something like this, then this guy, of course, is bigger than 0. Okay, and you have something like this. Maybe I just make it to. I don't know whether I make it to come to the graph. Okay. No. So that is what you expect to see when data. Okay, when you equal to 1, is exactly the graph you want. Is that okay? Is that okay for the graph you see? I think I get on the slide, but I'm not sure the one the slides perfect. And I think the slide has some. I think the slide has some issue. But let me tell you how to correct this. I guess you can add some more point here. Okay. And for the positive one, and upload a new one. This is also correct, but negative usually you have some more other point as well. It's also allowed. This is the graph is correct. Positive one should be not this. Sorry for the diagram. This should be positive should be something like this. Put the line there. For this guy, this is correct. So that we measure. Okay. So the next thing I want to mention is interesting thing is about the sample counterpart. For this mod, for the covariance coefficient is exactly same as the population version. Okay, so there's no distinction between them. The reason actually I put is shown here because it doesn't rely on the n. Okay? Because n they cancel out. Okay, so I guess I don't need to do the proof, but easily you can see because n minus 1 they cancel out, same as the n cancel out. So that's why because they all appear in the denominators of the cancel. Okay, so I don't think I need to go into details of this because there is something we don't need to. So I guess it's good to go over this example to show you how to do the calculation. So the data we have is here, x and y like this. Okay, this data. Okay, and you can easily check that the mean is 3 for x, and mean for y is 6. Okay, just to remind what the calculate 3 just 1 plus 2 plus 3 plus 4 plus 5 divided by 5. How to calculate 6 is 4 plus 7 plus 6 plus 4 plus 9 equals divided by 5. Okay. Now you can calculate for each data point, you subtract from their mean. Okay. This, all right. You just every entry minus 3. All right. Minus 3. From here, just minus 3. Okay. And this column, right? You jump to here, with -6, right? Because that's the mean. Okay, 4 minus 6 is -2, 7 minus 6 is 1, so on and so forth. And how you get this column number, right? That's multiplication, right? So we just multiply this, give you this, right? 2 times 3 is 6, negative times negative is 4. Okay. And the last two columns will be trivial, right? This the square, and this one is the square. Okay. So that's how you obtain every element from the table. Okay. Of course, it's trivial, but this teach you step by step how things being done. Okay. And this, the first element is 7, is adding up everything there. Okay. Summation of xi times yi. Remember, this is the numerator for covariance measure, right? If you divide by n, right, that gives you the population version of covariance. You divide by n minus 1, that give you the sample version. Okay, 7 times 5 or 7 times 4. Now the remaining part is to calculate the what we call measure of correlation coefficient. Right? But that one can be just figured out by finding the sum of this row, which is 10. Okay? And sum of this row is 18. Okay? And you can immediately see our formula here. 7 over the square root of 10 and 18 is already answered. Okay, so that is the fastest way to calculate the correlation coefficient. Okay, but as we know, we can use a method that rely on covariance and the variance or ST. Right? So you can actually, based on what we have here, calculate what is why this is 2 and 2.5, right? Because 10 over 5, this comes from 10 over 5, right? This comes from 10 over 4, right? Because this is this summation of the x minus x bar squared divided by n minus divided by n minus 1, okay? Same as how we calculate 3.6 and 3.5, right? 3.6 comes from 18 times 5, right? And 4.5 comes from 18 times 4, right? And you put, when you have this population version, you put the population version there. When you have sample in the numerator, and you put the sample in the denominator, okay? Regardless of what you calculate, this is 0.5. And you can easily see that they are possibly related, right? When you try to plot this graph, because when x increase, y can be increased. And look at the data. When 1, 2, 3, 4, 5, it's increasing x. And y is almost increasing, except the little bit weird case here. But still they are in the increasing trend. So, okay. So I hope this explains nicely about the covariance and correlation. Okay. So, is there a question? If not, then let me summarize. Basically, we are done with all the theory part of the topic 1. Of course, after the break, we'll talk about Excel. But before we break, let's talk about some application. Is there a question? If no, let's talk about some application before the break. So the question is again, why do we care about covariance? I mentioned already. But what is application? Okay. Application, as we are B school, so we're interested in, say, finance or marketing or accounting as well. But let's focus on the few applications we're all about. And in investment, we often actually a lot of time we talk about diversification, right? And talk about what's our vision, right? How to do it is to invest in the assets that are negatively correlated. Okay. So you want to invest in assets that one thing goes up and the other goes down, right? Sometimes for hedging, sometimes. So, and that's why when the market is fluctuating, a lot of people go to buy gold, right? Go to buy Bitcoin, go to buy when US stock is fluctuating, people go to emerging market, right? Why? Because the risk in the US market is less correlated with the gold, right? Less unrelated to emerging market, right? And that's why a lot of time you see people try to do investment in financial market that's unrelated to US, right? That's why the people invest in startup, right? Invest in angel fund, right? Those are ideas because of the unrelated. And somewhat is explained why the reason 5 years, 5 to 10 years about the US stock market has featured a lot of booming in the bubble from the China stock, right? Chinese company go to list in the US stock market. And why they do that, right? Why don't they want to list in Hong Kong? Okay? Hong Kong is also international market. Why do they in the US? It's because for the US investor, right? They will find the Chinese stock is more attractive than Hong Kong people, right? Because Hong Kong economy is correlated to China, right? So invest in Hong Kong, you already get the risk from China, right? But if you are US investor, right, your portfolio will be related to US stock market, right? But if you invest in some Chinese stock, right, which usually is less correlated, or even sometimes never correlated, the US stock, then you have premium. Okay, so that's why when the stock goes to the US, right, there's a lot of premium, right? The PE ratio is much higher than you. So that's why Chinese company also want to list in US. It's because of negative correlation. Okay? And the other explanation, maybe you want to see an application is like marketing, right? And the manager really want to see if one consumer want to buy one good is also easy to buy the other. So in that case, we send promotion, right? Suppose go to a cosmetic store, right? If you know that a customer is going to buy a mask, is going to buy buy lotion or buy some other things as well. I don't know anyway, but that would be you want to sell, right? And suppose and they sometimes want to do the bundle, right? And so on and so forth, right? Or they're negative related, and you will do other way around. There are a lot of marketing or sales as a thing about. So, right? For hotel management, people probably they also care about it. If the client is going to live in a premium room, likely he would want more room service, right? Or try to have more, spend something as well, then you probably want to sell, right? If you want to have some wine in this room, then you try to put a sale, right? If poor people like me, then they would not try to sell. That's the idea. And the other is finally talk about investment, and many of you probably will be interested in those. Is what do we learn in this class, right? In this first topic, we learn a lot of summary statistics, right? We talk about center tendency, mean, median, mode. We talk about dispersion, variance, IQR, dispersion, right? And we talk about skewness and kurtosis, right? Can we apply this in our investment? Okay. So here is some good stock characteristic, right? And if you want, holding other things equal, you want the stock have higher mean and high return, right? That is the mean, right? That's the idea, right? And of course, that's the trade-off when you talk about the market is efficient, right? When you have the stock have high return, you should expect to have more risk, right? So of course, that means that the stock has less variance, less risky will be a price of the market, right? You would prefer that. Okay. Assuming you are not really loving the risk. And that the first two is nothing you know very well, is well known in the classical finance model, right? And the third one is less likely you may notice is skewness. Okay? And actually skewness, although it's not well studied in the finance theory, but empirical model have shown recently, skewness is actually an important thing to be priced in the market. So if you want a stock that likely to have positive surprise, you need to pay a lot. Okay, it's not surprising if you know these days. Look at who is the most richest people in the world, Elon Musk. Right? Where his wealth comes from is his own holdings on his Tesla and also SpaceX. The main reason is Tesla, right? And Tesla, you know, the price is like something exponential, right? Of course, it's why it is going to be the case. It's not because of this is making money. Of course, it's Tesla make a lot of money, right? But doesn't imply this such a high price. It's because people still expecting a big surprise. Okay, yes, you can have a lot of growth potential, okay, and have a positive student. It's likely to go a lot. In that case, people have to pay premium for that. Okay, actually same as in 2006 and 7 when iPhone comes out, the people expect the company is going to be doing very well, right? You don't have negative risk, but you have upside risk, right? A huge upside risk. So that's why they price in the market. Okay. In the classical model, like CAPM model or other model, you may have known, or better, because the modeling they don't not yet talk about those. But these things are increasingly become important. Probably soon, 5 to 10 years down the line, then you will see skewness would be normal, right? Because traditionally we talk about finance risk and we can't do all. They seldom talk about skewness, but you know skewness is important. And of course, kurtosis, right? Kurtosis is something also very important, right? People actually these days they know they talk about what we call an animal, right? Because people are each talking about animals in the stock market, about bulls and bears, right? One animal. Recently, you look at the financial news, you know about black swan. Remember, black swan is exactly the kurtosis thing, right? Something very unlikely that actually happened. And we know COVID is like one thing, right? Something very unlikely, it happened, it affects so many people. Another thing is this year is like an unfortunate year, right? We have the war in Ukraine, right? It's also an unexpected thing, right? For those who have, I don't know whether you have CPF, but if you do, then you notice that your CPF will drop a lot, right? Because of the fact that the global stock market is not doing very well because of the inflation carried out by the war, right? So these are the things, right? Look at the kurtosis, whether they're risky or not is another dimension. Okay. So quickly, I'm not going to go into detail, but you can see that is something you expect from this class, right? You learn it, look at pre-investment of A, B, and C, right? A is mean of 6 and STDEV 5, B is mean of 6 and STDEV 5, C have a mean of 4 and STDEV 10. So which is a choice, right? And obviously A is better than B because they're same risk, but the other A is higher return. Look at B over C, right? You would prefer B to C because they have same mean, but B has lower risk. Okay, then probably you would say A better than C, right? A is has higher mean, but lower ST. Okay, so here I don't talk about one thing. Probably you would ask, some of you might be worry is what about B is mean of 10, okay, and ST is like 15. Okay. So how do you compare B to ABC? Okay. You don't have direct comparison because you need to tell me how the trade-off about the risk preference. Okay. Then for the market risk preference, in that case, you need to rely on model like CAPM. Okay, or some other model, arbitrage pricing theory, a lot of the models can tell you if you cannot tell, you need some formula, okay, to tell you this. But that would be the problem of what you learn in investment class, tell you what is the appropriate trade-off or mean and ST, right? And here I don't talk about kurtosis and skewness. You can see, you can also put in the formula to see which one you would be best investment. Okay, that would be there. Is that okay? So you can tell the sales part what we learned, right? It's somewhat useful. Right? And finally, I'm sorry, I'll take a little bit more time for your break, but I will give you enough time for break. So last one, so statistics and investment. So we talk about how to do the stock, right? And the problem is how usually lies on also is how do you optimize a portfolio, right? From what we learned just now is correlation is important, right? You really don't want to put what we call put all the eggs in the same basket, right? So what does that mean? Like you don't want the same risk appear to the basket, then the basket falls down, then all gone. Same idea, right? That's why we want to look at correlation, right? Look at the portfolio, are they correlated, right? That's not surprising these days, as you can see of rising probability, rising popularity of investment app that invest in U.S. stock market, right? Like New or those kind of stuff, right? And the reason why U.S. stock become more attractive to the people in Hong Kong, reason is because of a lot of people working actually have their risk exposed to the Hong Kong stock market, right? Because the CPF already invests in the local, and your job is local, so your risk is already, your economic risk or financial risk is already highly tied to the Hong Kong economy, right? So that's why you want to invest in the US stock. Okay. Some of you haven't been working may wonder why your CPF cannot invest in the US. I can tell you that if you try to look at the data, most of CPF only invest in Hong Kong or the Asia Pacific region. They don't go to the US. They don't go to Europe. Okay. So in that case, that's why when the app comes out, then all people go to there. Right? That's why also people go to buy a cryptocurrency, the same idea. Because you want a zero or negative correlation. Okay, or people in the old days, before you have this stock or thing, people invest in foreign currency trading. Right? Like you guys are too young, but when I was young, many people would stand in front of the bank and try to look at how to trade foreign exchange, right? People buy in British pound or Dutch mark. At the time, there's no euro, but people buy euro, those kind of things, trying to diversify the portfolio, right? Because exchange risk is related to economy of not local but foreign economy. In that case, it's likely to be zero or negative related, right? So in that case, that will lower your total risk of portfolio. Okay. So of course, there are many things you can think about, but we're not going to go into detail, right? That will be something reserved for other class, but just to remind you what we learned for the 3 class, up to now 2.5 class, a lot of things, I mean, that can be very useful, okay? And just in case you miss anything, you can go to watch the videos in the QR code, and they are recorded 2 years ago. So, but statistics, right? So be relevant 2 years or 2 years from now or 2 years later. So you can try to get. After the break, we talk Excel. In the meantime, I go around, do the break. If there's a question, you can ask me. So let's meet 10 minutes after. So it's like 1:35, 26, and we'll come back with Excel. Question? Oh, it's very close to this. You mean data in terms of CAPM or data? The CAPM is not exactly very similar one. The page is talking about how the stock is formed. You can figure using some regression. But regression, okay, the regression the coefficient is basically covariance by It's covariance of over that is because that is common. So what is it? Why contains? You don't because that is the estimated that well, we will explain it tomorrow. That is good. So put it because your measure so the base with the base the model normalize variance. So because the beta in the model can be any number, right? So that's why you have divide it. You cannot divide by y, then you have always and always yeah, different measures. You know at the end. You know when you talk about it. Little bit further ahead. More or less it's hard to correct. With a different formula. Hi, can you hear me? Good. So, I guess we should resume. Okay. So, many of you are a little bit worried about the formulas. Just want to say is the formula is not necessary to memorize because we are open book tests. Right? You can always refer to your notes and slides when you do the exam or you do the test. Okay. So now what we need to cover is go into the Excel. Okay. So I'm not sure how many of you have worked on Excel before, but I assume absolutely zero background for your Excel. Okay. We start from the very beginning. If you think you know Excel good enough, okay, you can follow by yourself. You can just enjoy your lunch, okay. If you think you're okay, then you can just follow. But we are going to be slow, okay, for this one, okay. So unfortunately, for the first time, we have to do it from scratch, okay. So open your Excel. I guess you all want to be different from mine because most of you I can see using iPad or using the MacBook, okay. But this would be very similar to what you have, okay. Even you are using the Mac or iPad, okay. So this is what we call the spreadsheet package, okay. And spreadsheet package or spreadsheet program, as you can see the spreadsheet here. So what's good thing about spreadsheet is you can see the data together with calculation on the same page, okay. So that is a combination of data and the calculations that make things distinct from software you learn from R or Python, okay. I don't know any of you went to the optional tutorial on last Friday, but if you do, then you notice that R will be different from what we are doing, okay. It will be more similar to the V.B.A, but in our class we're not talking about V.B.A. So anyway, so the first thing to do is to, because I assume you are still knowledge, let's start from treating this as a calculator first, and then you know how to do calculation, okay. So to start, you can start, because a spreadsheet, you start from any cell, double click it, or in case of iPad, you just tap on that. Then you can see the blinking cursor there. So you can do the calculation by starting from putting an equal sign. See, I think you can see. Maybe I make it even bigger. I don't know whether you can see. Okay. You have an equal sign here. Okay. And then you put what you want to do, right? The standard. Okay. If you want to do addition, you just do this, right? 1 + 1. Okay. Then give you the answer. Okay. And this is 2. Okay. One thing I will do for our teaching purpose is I will what we call with a function, which we would call formula test, which I put over there. Then I will show what I'm input there. So we'll talk about function in the later stage, but this is what is input in here. Okay. You can have equal to 3 minus 2. Okay. You can do addition, subtraction. Okay. And you can do multiplication, right? Saying this is a star is multiplication, right? And you can also do division. Okay. You can also raise to the power. Okay. And these are all things we need to do, right? The basic calculation: addition, subtraction, multiplication, division, and raise to the power. Okay. So these are the things that what we call the first set of slides told you how to do this. Okay. So I guess if you have know anything, then it shouldn't be a big surprise to you. Okay, should be fine. Okay. So this is what you will see, right? Now the next thing I want to talk about is square root and exponential, which we will need it for square root. We use it for our class, right? To get the variance from to get the standard deviation from variance and square root. Exponential, we use it when we topic 3. Okay. So let's go ahead to do square root. Okay. A square root of 16 is 4, right? So that is how you can get that. Okay. Exponential is a natural number. Okay. Is this 2.78 raised to the power 2. Okay, in that case. Okay. So these are two, especially square root is important measure. We will use it soon. Okay. So these are all the calculations. Is there any question? Okay. Although I'm slow, I'm a little bit. If you haven't touched it before, then you may be fast. If there are questions, let me know. You can, because this is more like tutorial style. In the last year, we do it in the lab. but because of lab, it's very difficult to book. So that's why this year we put it here. But you can consider this as tutorial style. So with your question, just ask me. Okay. Any question? I'm not going to go around because of to save the time. Okay. If a question, just raise your hand. Any question? And then the other question? No. Okay. So here we can try to do some calculation. We'll do what we call count and the sum. Okay. So these are all the first, probably the first function that try to calculate. And you can notice for the purpose we do the function is enclosed by bracket, right? Actually, we implicitly use it when we talk about square root. And to input data, Excel use the curly bracket. Okay, you could put curly bracket to put it. Okay, this function give you how many of them, and the sum function give you the product. Sorry, the sum of them. Okay, so let me do it here. Okay, let me do it here. So let me do the sum of 1, 2, and 3 to make it simpler. Okay, sum of 3 should give you the answer 6, right? Because that is the number here. And I do the yellow in case you would same as the book you have. Okay, the sum. Okay. Maybe I do the count first, right? I do the count first. Sorry, I do the count first. Don't worry if you miss the slide, to miss the Excel. I'll upload the Excel file at the end of class. Okay, so you don't have to worry. And the sum of 1, 2, and 3, and 4, say. Okay. Okay. So this is how you use it, right? Easily by construction, you can easily calculate average, right? So suppose you have sum of 1, 2, 3, okay, divided by count of 1, 2, and 3. You can easily see that this should give you the average, which is 2. Okay, so that is how you can do things from scratch, right? This is the average. Okay, so probably you would be thinking that do Excel have a function directly calculate this? The answer is yes. It's called average. Just average 1, 2, and 3 will give you the same answer. Okay, so we learn our first Excel statistical function, which is called average, which you give the mean. Just average. Okay. So you can, if you want, you can go back to the slide. You can see average. Okay. So I just skip a little bit about the rundown, but just the same as the function that run down of that. Okay, but I'm not going to go into detail, but just run down, just give you the integer, run up, you just go to the largest integer that is there. Okay, and we mentioned the class we have geometric mean and harmonic mean, just call it geo mean and harm mean. Okay, I'm not going to write on the Excel spreadsheet because but that's how you calculate geometric mean and harmonic mean. Is that okay? Okay. So I think this is something worth telling you, is how to do the weighted mean quickly. Okay. Which will rely what we call sum product. Okay. What sum product here is how you calculate the numerator for the weighted mean is you multiply each observation by its own weight, right? The data is 1, 2, 3, 4, 5. The weights for 1, 2, 3, 4, 5 are 6, 3, 3, 6, 3, 2, 3, 2 is exactly the example in the slides. Okay, so that's how you do sum product. You get the number here, and you get the second number here. Okay, the first is the number, then this is the weight, and you divide it by sum of the weights. Okay. And unfortunately, Excel do not have a built-in package for this. Okay. So you have to do it like what I'm doing. Unless you know how to do VBA, in that case, you can just define it. But for the moment, we're not talking about VBA. So that is how you get the weighted mean if you really want to do it. Okay. The next thing I want to talk about is median. Okay. And you can easily say median immediately give you what we want to do, right? Median 1 to 3 of 5 to 3. Median of 1 to 6 gives you 3.5. So I just illustrate once for the median, okay? Because with mean, you want to show the median, right? MEDIAN, open bracket, open curly bracket, and you put 1, 2, 3, 4, 5, 6, or maybe 7. We just make it more fun. And you close the curly bracket and close the normal bracket. Put enter there, okay? So that gives you the median. Okay, you should try out yourself to figure out the mean and the median. Is that okay? Maybe at this moment, I just go around to check out. If you have any question, you can ask me, because computer is always sometimes not clear if you have a problem or not. But if you work it out, hopefully you can try. I mean, as long as you are done, you're okay, then it's okay. You can use your phone or use your iPad or your computer. You can be able to figure that out. Okay. I hope you try. If you know, then it's better. The curly bracket is needed when you are inputting a list of numbers. So because 3.90 means you run down 3.9 up to integer. If you run down up to 1 decimal places, it's 1. It's only m input to number because it's curly bracket is a list. The curly bracket means list of sum is 1, 2, 3, 4. So it's a number that you put into the data. So in terms of computer science terminology, that means that you are inputting a vector array. That thing is a list of things you put in the thing. Of course, you may ask, if you don't have the curly bracket, will it work? It will work for our scenario, but it wouldn't work when we have some product, because you have to input 2 lists, then you have to tell them which is which. Is that clear? Yeah. Now we have mean and median, right? The next thing you want to know probably is mode. But before I talk about that, I want to tell you one thing is like what we call cell reference. Okay, cell reference is very important in Excel calculation. Okay, because there's a good thing about spreadsheet. You want to display the data together with the result. Okay, so that's why doing this is a little bit tedious, because you need to put the data in, right? Usually you see this and not clear what's going on. So let me open another spreadsheet. Okay. So here usually what you get is you have data. Okay. Maybe the data stored in the horizontal format 1, 2, 3, 4. Okay. And say like this, right? Okay. And you want to know some summary statistics, right? You want to know the mean, you want to know median, okay? And of course, you really don't want to repeat yourself, typing the formula, turning the data into the formula, right? So how do we go and do about that? Is what we call self-referencing, okay? So we will call average, okay, of, instead of telling them the data directly, you tell them where to get the data, okay? So that is to use a spreadsheet. You tell them, I want to calculate the mean using the data from A2 to A5. So you've got A2 comma, colon A5, okay? So that is the way that you would make sure that your formula is different from data, okay? The data is there. The formula refer to the things in the spreadsheet, okay? So let me do a thing to show you this one, okay? So this is showing you the this is the equation there, right? The average, okay? So in that case, you don't need to tell the spreadsheet what the data is, and it's good when you change the number, right? Suppose I change number to 5, okay? You can easily see the number changes accordingly, okay? So same as median, I can do the same thing, median there, okay? And instead of typing A2 colon A5, I can just do mouse click or your tap in your finger. Just try to use the finger to tap this and scroll, okay? Okay, or use the mouse to do the same. Okay, close it. So you do the median. Okay, you can see if I change the number here, the mean changes, the median does not. Oh, exactly what we're expecting to see. Okay, is that okay for this one? I mean, if you have learned Excel, it would be easy for you. But I just, if you haven't learned anything Excel before, that would be something not trivial. Okay, and here I don't want to go into more details, but just to remind you that one thing that distinguishes you as a good Excel user or intermediate one, right, is whether you know how to use absolute address. It's because of what it is when you copy and paste, okay, whether your cell reference is moved with you. If you don't want to move with you, you get a $ there, okay, and that will be important. We don't elaborate the reason, but you will see that will be important when you want to become an advanced user, okay, but we don't want to go into that detail, okay. So the next thing I want to show is, for our purpose, it is easier when we have the date, when instead of calling A2 to A5, is there any way you can make a name so that you can refer to it easily? I think that would be more important, okay. It's the following. So-called formula here, okay, and we call define name, okay. So you can see I highlight this, okay, I highlight this, okay, and we call define name here, okay, and automatically or whatever the where smart the Excel already suggest the main data, okay. So where's smart name? So here is data. The scope is the whole workbook, or I just need the worksheet, but anyway, just the whole thing. In this one, he just say worksheet 2 from A2 to A5. This is called data. Okay. So when I click OK, what it will happen is Excel remember the name when I type data. It's exactly this number. Refer to this number there. Okay. So what is the purpose of doing that? Suppose I have this, and you will see why this is the better one. Better than doing this, okay? Let me show you, okay? What I'm going to do is I will do average of data, okay? When I put data already there, okay? So you would make sure that you don't need to worry about what's A2 to A5, okay? What's the cell there, okay? The same number, right? Median of my data, okay? Of course, you can put your name, okay? You can put apple, orange, whatever name you want to name, but once you have that, your code is become cleaner, okay? And for people who don't know your worksheet, can just go to name manager and try to check out, okay, what's the meaning of your data, what's the value there, then they're done, okay? So that means that you don't need to let other people to worry about reading your command, okay? Either will be good. at least it's better than like this. Okay, because here you have to check, oh, what is this number there, right? Then not that easy to see. Okay, this is already improvement. Okay, and further improvement can be made by doing this. Okay, so I hope you would try to be more careful when you try to do Excel, because when the spreadsheet is huge, you may just miss 1 point or 2 points using this idea. Because if you keep doing this A2 to A5, you may lose track, right? Because you always, if you frequently use a data series, it's better to name it in a name that you will not confuse. Because if you have multiple main rows, you may just you may just forget, right? Because you may add new data to your new entry to your data, then you may lose track and you can make mistake easily. So I hope this will be useful tools for you. Anyway, I hope this will be useful because so this is how you can see the example I have, right? You have 2 data series. That's how you do the average and median. Okay. So I'm going to skip exercise. If you want, you can have fun, but just have it. We don't have time. So let's define the name. I just show you. Now the next thing is I want to go through the mode. Okay, the mode. Okay, mode single. Okay, it's looking for the mode. Okay, so let's go back to here. It's easier to show you the mode. Okay, it's called a mode. You can see we have mode single and mode multi. For purpose, we just use mode single. The reason it's called we don't focus on mode multi is because mode multi is a more complicated idea we call array function, which is beyond the scope of our class. So we just focus on mode single. Okay. If you want to know, you can do it. You can check it out by yourself, but we focus on mode single. So we just put it in, say 1, 1, 2, 3, 4. Easily you will see the mode should be 1. Right? So that is how I do the calculation, the mode. Okay. When you have more than 1 mode, I think the Excel will give you the smallest number that reach the mode. Okay. So, but that would be the how Excel do the calculation. And if you have things that only appear once, then have no mode. Okay. But remember, we define differently for our purpose. For our class, we define mode is 1, 2, and 3. Okay. So just to make sure that you understand that. If you learn R, you will see why we are defined this way. Okay? So with R, you can define most frequent data, MFX, that will actually same as what we learned in the class. So that's why what I try to define is similar to what R should define. Okay, it's different from Excel. Now we know mean, median, mode. The next thing probably is just trying to show you how to do range and IQR, right? Range and IQR. How to do range and IQR? Okay. Range will be just the difference between maximum and minimum, right? So let's do that. To save space, let me copy this. Let me do this here because that will be easier. Because in this case, we can start using this formula easier. Mode will be just equal to mode single. I just highlight this. It's easier. Okay. So in that case, no mode, but let me have some more. Let me change it. Okay. And then we change A5 to A6. Maybe we have 3. Doesn't matter. Up to A6. One more. We have A2 to A6. Okay. So in that case, we have mean, median, mode. Okay. So let's do the range thing here. Okay. range will be the maximum and the minimum. Okay. What is the max? What's the minimum? Okay. And do the range. Okay. Max will be just doing the max. Okay. Just put in the number there. A2 up to A6. It's a max. Okay. And we can do the same for the minimum. Minimum A2 to A6. Okay. So that's how you get the maximum and minimum range. Okay. And range will be just simply max A2 up to A6 minus minimum A2 up to A6. Okay. So that is how you can do to get the range. Okay. That's how you get the range. This is the range. Let me copy it and I do. Let me do the IQR. Okay. So let me erase this. So I want to do IQR. How can I do IQR? IQR, I need a Q1, right? Q3. So that would be, I need to do IQR. So how to do Q1 and Q3? There's a formula here, what we call quantile exclude. Okay. Q1 will be 1, Q3 will be 3. You can imagine median, which is Q2, which is 2. Okay. And as I mentioned in class, Q0 the minimum, Q5 will be the maximum. But we just need, for purposes, need Q1 and Q3, right? So let's see how we do it. It's just like quantile exclude A2 up to A6. Okay. Quantile 1, just 1. Okay. And do the same quantile A2 up to A6, we need 3. Okay. So this is how you get these two formula. Okay. And as easily you can see how can we do the IQR. Either you can type the whole thing again, but since we have the calculation here, we can just like C4 minus C3. Okay. So that would get what we want. Of course, you can just type out the whole formula, put it there, quantile, exclude, blah, blah, blah. But I think that is easier to do the calculation. This is IQR. Is that okay? Okay. Then maybe I create another one. If there's no question, I would do the variance measure. Okay. So look at different variance measure. Variance, okay. I would have, for the variance, I have 2 versions, right? With the pop version, we have the sample version. Okay. So what are the formulas here? It's very simple, just VAR.P is the variance version. Will be A2 up to A6. That is the variance version. Okay. And if you want the sample version, it will be VAR.S, which is A2 up to A6. Okay. So this is how you can get your number for the variance. Okay. So immediately you can see we can do SD, standard deviation. Okay. We also have the population version and the sample version. Okay. So how do we do that? The formula will be STDEV.P A2 up to A6, for example here, right? So this is the formula for population. And we can do STDEV.S A2 up to A6. Okay, so that's how you do the ST. Okay, and one immediate question out of your mind probably is how to do CV, right? Right. So that shouldn't bother you, but do remember you have two versions again: population version and a sample version. Okay. Okay. And let's see the formula. It is population version will be population SD divided by the mean times 100. All right, look at the formula. So that's what we do is STDEV.P A2 up to A6. That is the numerator. We divide it by the denominator, which is the sample mean. That's the average. A2 up to A6. Okay. Remember, we're not done yet. We have to multiply by 100. Okay. So that is how you calculate CV, population version. And easily you know how to do the sample version is by just change the P to S, right? So to show you, let me do it again. The numerator will be STDEV, standard deviation, dot S, A2 up to A6, okay? And you divide it by the same average, okay? A2 up to A6, okay? And times 100. At this moment, I want to stop a bit to go around to see if any question. Any question? Just go around, try to see if you can follow. Of course, you'll be test this knowledge when you do the assignment and when you do the your final project. You'll be working on that as well. I guess you'll be doing Excel, so I'm not worried about that much. And I'll upload this file on the Blackboard after the class, so don't need to worry too much about it. If you don't follow, just see. If you still really can't do it, just ask the TA to see if he can help you more on this. But I think it's okay for this dispersion part. Okay. If that's okay, then talk about shapes. We talk about kurtosis, skewness. Okay. So quickly, I go to the shape. Let me copy this. Shapes. Okay. So I would have skewness, okay, and kurtosis. Okay. Let me clean this out because I don't need them. Okay. So I don't have that yet. Okay. And for kurtosis, I don't have sample version. So it's very simple, much easier. So these three are the things that you can see in Excel. Is kurtosis. Actually, this should be excess kurtosis. I should be a little bit more precise. It's excess kurtosis. Because they don't give you the kurtosis, it's excess kurtosis. Okay. So for the population, no surprising, there will be skew, dot P, A2 up to A6. They will give you the skewness measure, which you can expect very reasonable because we have a positive outlier. The skews is 1.3, right? So that will be something you would expect to see. Okay. And for the sample version, it's even easier, just skew. Okay. It's good thing the skew because the sample so often used. Actually, you don't have to say dot S. Okay. So the skew is 2. Okay. And you expect because the skew if you use the population version is underestimate. Okay. So that's why the actual skew is 2, is much higher than use the underestimated one. So that's why I use this one, right? As I told you. You always use this one for your, what happened? Hey, don't hang. No. Hey, no. Not fun. Hey. Hey, what happened? Okay. Hey, it's not fun. I mean, I don't know if even Excel can be hanged. Okay, just wait a second. Okay, that's not good. Okay. So the sample skew kurtosis will be just cut of this guy. Okay. So this is the what we want. Okay. So let me quickly. So I hope it's still okay. So this is the file. Don't worry, if I miss anything, I'll try to get back the right file, put it on the website. So don't worry. So just I guess I mean it's time, so I don't want to keep you more. So next one we talk about correlation, covariance in the next class. So I just keep it here, and I upload this file on the Blackboard. Okay. So I see you next week. Oh no, see you on Wednesday. Sorry.